Hey guys, Professor Goodman here. We're going to go over the homework for chapter 16.3. So this will be the last, this week we'll have the last bit of chapter 16 homework. So this will be the sections 16.3 and 16.4. 16.3 is just, last week we did confidence intervals, right, with difference in population proportions. Well, now we're going to do the hypothesis test for difference in population proportions. And then 16.4 is just a summary of all of them. Okay, so let's get started. So I'm going to skip this first question because a lot of these questions are pretty much the same, but I think the last two questions were the ones that I wanted to answer. So question 4. A researcher makes the claim that within 1 year of divorce in the U.S., women have a lower suicide rate than men. Well, this is a cheery example. The research collects 2 random samples from the population and finds that 87 of 2,386 women committed suicide within the first year of divorce, and 110 of 2,416 men committed suicide within the first year of divorce. Okay? Interesting study. So, first off, is this an experiment or an observational study? Okay, so this is just asking what type, like how do you think the person or this researcher got this information? Well, an observational study means like, he looked it up or he observed, he obtained the data through, I don't know, some kind of uh, database or somewhat. Experiment means he actually went out and did it. So if you're reading this problem, you would hope it was an observational study, because if he was experimenting, well, that'd be a lot of people he's studying and saying, hey, are they going to commit suicide? Yeah, not good. So definitely not an experiment, right? He didn't actually go out and take these people and expect them to commit suicide. So it was definitely an observational study. Okay, so that's the first part. Um, so let P1 be the proportion of women who commit suicide within 1 year of divorce, and P2 be the proportion of men who commit suicide within 1 year of divorce. Okay, so remember, P1 and P2, these are our population proportions. They are not our sample proportions. Our sample proportions are P hat, right? So anytime you see P hat, that's your sample proportion. Okay? So here, the null hypothesis, so H sub O, is P1 minus P2 is equal to 0. So, in other words, just like before, in our confidence intervals, we were doing the difference between proportions, right? Well, the same with hypothesis testing. We're going to be testing the difference in proportions. So here, we assume there is no difference. We say that P1 and P2 are the same. Well, what does that imply? That means that if you subtract or find the difference between the two of the same number, you get 0, right? If P1 was 0.5 and P2 is 0.5, then 0.5 minus 0.5 is equal to 0. That's what we assume is true. So, but what we're going to try to do is, with the alternate hypothesis, we're going to try to change this around. So P1, remember, that's women, right? Suicide rates of women. And P2, suicide rates of men. So what are we trying to answer in the question? So it says, portion of men who commit suicide within 1 year of divorce. The null hypothesis is, so right now we're trying to identify my alternate hypothesis. A researcher makes a claim that within 1 year of divorce, women have a lower suicide rate than men. Okay, so this researcher's claim, you're the researcher, this is your claim. You say, okay, I actually think women have a lower suicide rate than men, which then translates to this, right? So if we are doing this, so here is P at 1, P at 2. This is proportion of women who commit suicide, right? After divorce, but we don't really need to say that, I guess. And then P at 2 is proportion, same thing, but this time now it's men. Okay, so just delete the whoa. So here we go. Proportion of women who commit suicide, proportion of men who commit suicide. This is my P at 1 and my P at 2. So this is what we're going to have, right? It's always P at 1 minus my P at 2. Okay, so they said, what did they say in the problem? I don't think they say, but they do say P1 is women and P2 is proportion of men. So they say here it's going to be the difference of women and men. So women minus men. So it's my P hat 1 minus P hat 2. Okay, so think about this. All right, so we got to think about this in terms of the difference. So here we say we want women to have a lower suicide rate than men. So what does that mean in terms of proportion? Well, that means that we want P1 to be smaller than P2. So if we're subtracting P1, which is smaller, and P2, which is larger, what kind of a solution are we going to get? We're going to get a negative answer, right? So we want it to be less than 0, right, for our alternate hypothesis. So P1 minus P2 should be less than 0. So see, this is what we want. See, let's double check. It should just be less than. Yep, just less than, right? Because if I say, let's just say, I don't know, this is 0.5, and let's say this is 0.7, right? So we're saying the proportion, that's a large proportion of men and women who commit suicide, much larger than the real thing, but let's just pretend these values. Okay, and I do my P hat 1 minus P hat 2. If I want P hat 1 to be smaller, look, I get a negative solution. So if I want P hat 1 to be smaller than P hat 2, I'm expecting my P hat 1 minus P hat 2 to be less. So P hat 1 minus P hat 2 to be less than 0 is just what that's saying, right? That's all I want. Okay, so of course they give us our actual P hat 1 and P hat 2, so we'll get those. But that's just how we identify the correct alternate hypothesis, or alternative hypothesis. Because here we have the difference is 0, and then here we say, actually we think women commit suicide, a smaller proportion of women commit suicide than men. So in other words, this guy's smaller, this guy's larger, so if you're subtracting a larger number from a smaller one, it's going to be negative, so it's going to be less than 0. And that's how you identify that. So maybe a little tricky, but you'll start getting used to it. Okay, so right away it asks us for the p-value. So this means we have to calculate the test statistic, right? So we need all of our information. So let's start throwing that information in here. So let's see. So here, 87 of 2386 women. So that's my p hat 1, right? So was it 80, 83, did it say? 87. Okay, so let me close this off a little bit so I can see the values. So 87 divided by 2386 is my p hat 1, right? Because this is the proportion of women who commit suicide. Then for men, they say 110, 2416. So it's 110, 2416. Okay, so then my p hat 1 minus p hat 2, take this guy minus this guy, and there is my p hat 1 minus p hat 2. Okay. So let's just keep going along here. So my P, now I need my like N1, right, my N2, in order to do the full formula. So I have all this stuff. 2386 is N1, 2386, right, because that's just my sample size. And then N2 was the 2416. 2416. Okay. So this is pretty much all the information that I need. Now remember here, first things first, look at the formula. So you should have the formula. The notes will be up for you guys to grab the formula. Look, this is how you find the test statistic, right? You can do what they do here and split them up. So here they find the standard error first, and then they find the test statistic and so on. You can do all this. You can do all of this stuff if you want to. But first things first, gotta find this dude. Okay, so we have just about everything we need, but we need this little guy, P bar. So this is my pooled proportions. This is kind of like, think of it, it's like the average proportion. Okay, so let's see what this guy is. Okay, so first things first, we'll find him, then look at these. So my standard error here, remember we did standard error last week, and then here is the actual test statistic. So this is the whole process that we have to do. All right, so we need our p bar as well. I'll just call it p bar. Okay, and then once we have all of that, we can do this. Okay, so if you want to, we know our x1 and x2. That's just the number of people in our study, right? That we wanted that had the thing. So 87 people committed suicide. So 87 plus. Then for the men, how many men killed themselves? 110. So plus 110. Then you just divide by the sum of your n's. So this guy plus this guy. Okay. Let me try something. So see, I think this works too. Nope. Well, it's close, but not close enough. Never mind. Okay. So here we go. This is all of the. This is what we need for our p bar, right? So, got our hypotheses. We need our p value. So first thing, we got to find our test statistic, z. Now in a remember that in a proportion, it's always normally distributed. So we're going to have a z-score for our test statistic. All right, so this is the process. So I showed the formula there, so if you need to, you can rewind the video and look at the formula. But first things first, you take your difference, your p at 1 minus p at 2. Okay, so remember that's the first part, because it's your difference in p at 1 minus p at 2. Then it's your, I'll just put it down here. So for my test statistic here, it'll be p hat 1 minus p hat 2. Okay, so that's this part. So it actually needs to be all in parentheses because this is just the numerator part. Then it's minus p1 minus p2. So you have the difference between the differences in my proportions. Okay. All right. So now that's the numerator. Now the division part, or the denominator, this is just going to be your standard error, your estimate, your standard error. But this time now it's going to be using p bar instead of the other stuff. Okay, so square root, and then you have your p bar times 1 minus p bar. So the p bar we already calculated. Okay, then you divide by your n1. Okay, so that's the first one. Then you sum your p bar times 1 minus p bar. Okay, so remember that's multiplication. Divide by n2. Okay, and close off all those parentheses. So this is going to be our formula. This kind of nasty looking guy. All right, so let's do it. So first things first, I have my difference up here, right? My p at 1 minus p at 2. Put that in its own set of parentheses. Okay, now minus. Ooh, do we know our difference between p1 and p2? Well, we don't know exactly. Like, we don't know the proportion for the population of women who commit suicide and men who commit suicide. But wait a minute. Look at this. Look at our null hypothesis. If p1 minus p2 is equal to 0, then doesn't that mean they're both the same, right? If you subtract two numbers together and you get 0, that implies these two numbers are the same, right? 5 minus 5 is equal to 0 because 5 and 5 are both the same number. So in other words, we're assuming p1 minus p2 is equal to 0. So then it's just 0 for that part. So you don't even have to put it there, but I'm going to just so you guys can see. Okay? Now we got to do the standard error. So square root. So let's open this up. Now I need my p bar 1 times 1 minus p bar. Right? So then divided by my n1. Close that off. Alright, so that's the first guy. Now let's do it again. So now I need my p bar times 1 minus p bar. Okay? Divided by n2. Okay, red closes off the fraction, black closes off the square root. And there is my test statistic. Alright. Okay. So now I need to find my p-value. So let's find the p-value. So remember, p-value, this is the probability, the test statistic in the direction of your tail test. Well, in our hypotheses, just let me throw them down here really fast. Let's just, down here, I'll just put my hypothesis, because I kind of forgot to earlier. Okay, so my H sub O and my H sub A. Okay, so they all deal with the difference in proportion, so it's P1 minus P2 is equal to 0. But then here I say P1 minus P2 is less than 0, right? That was my alternative hypothesis. Okay, so now since it's less than 0, this means that which way are we moving on the number line? We want this difference to be to the left of 0 or to the right of 0? Well, if we want it to be a smaller number, so we think about it on the number line, it's to the left. So this is a left tail test. Right? Okay? Nice. So we're going to find the area to the left of my test statistic z. So let's do norm.s.dist. You can do s.dist because this is standardized. That just means that my mean is 0, my standard deviation is 1, right? And there we go. So about 5-ish percent. Right, a little more than 5%. I think that's what they got too. Yeah, about 5%. 5 wouldn't really be able to reject it at the 0.05 level, but eh. Okay. What conclusions can be drawn? Assume a significance level of 5%. So that means my alpha is 0.05. So wait, which one's bigger? Ooh, this guy's above 5%. This guy is 5%. So what do? Well, p-value, unfortunately, is greater than my alpha. So this means we fail to reject the null hypothesis, right? So the H sub O. So then this just means we didn't find significant evidence to support our claim. So this means that we cannot reject the null hypothesis, and we can't conclude that fewer women than men commit suicide within 1 year of a divorce, right? So that's just what that means. And conclude that we did not find significant evidence to support the claim that women have a smaller suicide rate than men in divorce, right? Or divorce. Okay, so that's just what we're saying, right? So then what are we saying? Well, p-value is greater than 0.05, therefore the researcher cannot reject the null hypothesis and cannot conclude that fewer women than men commit suicide. This means he cannot conclude this, right? So this means that this statement here, he did not find enough evidence. So this is the correct one. He cannot conclude fewer women than men commit suicide within 1 year of divorce. Now, it could still be true, but with his sample, doesn't seem very likely, at least not with his sample. Okay? So let's put all these in. Oh, dang it, I forgot to put my p-value in there, right? Drat. Oh well. We saw that we got the same p-value anyway. What does it say? It wants it to 4 decimal places. Remember, don't look at this. Look what it asks for. It asks for 4 decimal places. So 1, 2, 3, 4. All right. So then everything after that. Okay. And there we go. All right. So actually, I feel like that's a pretty good problem. Most of these are, they're all the same thing. The only difference is maybe setting this one up, right? So it actually gives you some data. Take the data, and then, so you guys should know how to do this stuff, right? Do your whole count function. Count all the ones, or use countif function. Count all the ones, count all the zeros, right? And then you get your proportions for your treatment group and your control group. Okay? That guy shouldn't be way too bad. That's really the only difference, having to find that. So the rest of these problems you guys should be able to do. I just wanted to do this one because it was fairly well-rounded, especially because it had the analysis at the end, whereas this one doesn't. It just says, can you reject the null hypothesis and say the compound made a difference. Not really too much of an analysis. The other one was a little better. Okay, so let's hop on over and do a tad bit in 16.4. Now 16.4 is a summary chapter, so that just means that you guys have already seen this stuff. So I'll just kind of glance over it, and you guys should be able to do it. But for the sake of time, I won't go through a lot of the problems because you should already know how to do these. Like, see this problem here? You guys should know how to do this stuff, right? So my N1 times P1, well, just take these values up here and perform these products, right? And then after that, that's it for that problem. So let's see, what are the standard error of the difference of samples? So we should be good at standard error too. Think of it, remember, it's like standard deviation. There's that whole formula for it. The standard error is this guy right here, right? Oops. So this part is my standard error, remember. So you should be able to calculate that, right? That's actually the homework that you're doing that was due past Monday, right? Okay, so you should be able to do these guys. Yeah, you should be able to do all these. And then here's a confidence interval problem. So you guys should remember how to do that one as well. So actually, all these problems, it's literally a summary. So I mean, most of them are confidence interval problems dealing with two different types of proportions, two population proportions, and then it does have a problem like this. Oh, well, let's see. Now they're talking about type 1 error. Did not see that. Okay, well, let's look to see what type 1 error and type 2 error are. So let's see. Yeah, here we go. So my type 1 error. So type 1 error, and we have type 2 error. Okay, so we'll talk about this in class, but just for the sake of this video, in case you weren't able to go to class or you forgot this, I want to talk a little bit about this. And actually, pretty good solution, pretty good summary. So type 1 error is committed when the null hypothesis is true but is rejected, right? So why would that be a problem? Well, that just means that our sample was a bad sample, right? Our sample, well, maybe we thought it was a good sample, but it was like an outlier sample. So we take a sample and we're like, oh, hey, look at that. We can reject the null hypothesis. But what if the null hypothesis was actually true? Like, I know an example I used in class, what if somebody is testing, maybe they think that the Earth has been shrinking over the past several hundred, maybe 1,000 years, and they think that maybe our gravitational, the gravitational pull of Earth is no longer 9.8 meters per second squared. Well, what if they take a sample of, I don't know, some kind of rates or how objects fall or something? They take a sample, and it actually makes it so they reject the null hypothesis. So they're like, oh, it's not 9.8 meters per second square. Maybe it's smaller than that. Well, you know, we still believe to this day 9.8 meters per second square is true, right? That's still the acceleration due to gravity. Well, with that one sample we got, we actually rejected the null hypothesis, and we said, actually, maybe it's smaller than 9.8 meters per second squared. And you can see where that's a problem, and that can happen. So type 1 error is when this happens. So type 1 error is reject null hypothesis when it is true. So when it actually is true, your sample rejects the null hypothesis. That is your type 1 error. So then what do you guys think type 2 error is going to be? Well, it's going to be you take the null hypothesis, it's false, but you are not able to reject it, right? So null hypothesis is false, but cannot reject it. So what does that mean? That means that I took a sample and at the very end my p-value was too large, which means I could not reject the null hypothesis, but maybe we know that it is false. Like maybe we carry out other studies and find out that it is actually false. Okay, so those are the two different types of errors. So let's go back to this problem and figure this out. So let's see. Consider a null hypothesis, alternate hypothesis. If random samples are collected from each population, statistics are analyzed, and results are determined to be statistically significant. So what does that mean? Well, that means that we found enough evidence to reject the null hypothesis, right? So which option or options best describes the type of errors if the null hypothesis is actually true? Okay, let's go back to this. Type 1 error, we reject the null hypothesis when it is true. Type 2 error, null hypothesis is false but cannot reject it. Well, we found significant evidence, so we rejected the hypothesis. So that means that type 2 error is not correct. That means it should be a type 1 error. So type 1 error was committed as the null hypothesis was true but was rejected due to significance of the hypothesis test. So that's one of the answers, right? So let's see if there's any others. They say which of these best described. So let's see if there's anything else. Type 1 error was committed as the null hypothesis was false but not rejected. Nope, that's type 2 error. A type 2 error was committed as the null hypothesis was false but not rejected. Okay, so therefore a null hypothesis was rejected. Which option best describes the types of error if the null hypothesis is true? It should just be, yeah, that one. I don't know why they do I don't know why, but anytime I see one of these problems where it gives you multiple choices, I always feel kind of weird just selecting one. But yeah, none of these answers made sense to me. Just this one, right? Because it just says what is the type of error you'll get when the null hypothesis is true, but you rejected it. Well, that's the very definition of a type 1 error. You rejected the null hypothesis when it was true. Okay, so check answer, and voila. There we go. Okay, so here's just more on type 1 error, type 2 error, more on experiments and so on, and response variables and explanatory variables. That's a long time ago we talked about those, so that'll be good practice again. Alright, but most of these problems you guys should be able to do now. Okay? So hopefully this video helps you guys while you're doing your homework. And that's it.